Now, what is the value of my y2? What other notation does this my y2 represent? It represents f of x plus h. That is f of x plus h. All right? Minus, what does my y1 represent? It represents f of x. F of x divided by, so what does my x2 minus x1 represent? It simply represents h. Because if I take away x1 from x2, I'll be left with this distance. It is the distance from here to here that needs to be added to x1 to give you x2. So this x2 minus x1 simply represents h. And this is my formula for finding differentiation from first principles. But like I said, it doesn't stop there. Now there's something that makes it more interesting. Using this formula alone wouldn't be accurate without something called the limit. Now what's the limit? Let's go back to our graph. Remember, we were looking for the slope of this graph at this point. So why are we actually starting from this point? Doesn't that give it such a wide range? So what do we need to do to be as accurate as we can be? First, if we decided to find the slope of this graph at this point, I mean only this point, it required that we need to simply draw a tangent. And that tangent is a line that simply kisses. It simply kisses this curve. All right? So if it only kissed the curve and we're looking for that slope at this point, it means our value is simply going to be 0. Because this is like the point where it just starts. And if it doesn't move, it doesn't add anything. So it's simply going to be 0. And 0 is like an undefined value. All right? So how can we get as close as possible, but not necessarily get to 0? So imagine you could take your hands and simply move this point along this curve. All right? Assuming you could take your hand and you keep on moving this particular point along this curve so that it tends towards this point. What would you notice? You would notice that the value of your h would keep on reducing. As you're coming down, you're moving towards this point, the value of this h will keep on reducing and reducing and reducing. And if you dare to get to this point, the value of this h would automatically get to 0. But remember, we do not want to get to 0.